these are the various problems that I'm going to be solving in this video. If you wish to skip to any one of them, please select one of the links to the left. Okay, these are the following exponent rules that we'll need to solve these two problems. Now there are more exponent rules, these are just the only ones we're going to need for these two problems. For this problem, to be able to multiply these two expressions, we're going to need to use this rule here, the one that says if you have two factors with the same base and being multiplied by each other, then you simply combine them into one factor with that common base as the base, and then the exponent will be the sum of the two exponents. Okay? So essentially what this is saying is you kind of split it into three mini problems. One is the product of the two constants, the next would be the product of the two x's, and then the last one would be the product of the two y's. Okay, so we would do negative 8 times 2, so that's negative 16, x to the third times x. What we're going to need to do, since they have the same base, is combine it into 1, where this will have the common base of x. And then the exponent will just be the product of these two exponents here. Well, because this one doesn't have an exponent listed, it is assumed to be 1. So the exponent on our answer will be 3 plus 1, so x to the fourth. Then for the y's, we just do y to the 4 plus 5, or y to the ninth. Now this next one is going to use actually all of these rules. Now, while there isn't necessarily an order of operations for dealing with exponent rules, it's generally best to try to simplify anything within the parentheses first. Now, we don't have to do that. We could apply this squared to each one of the factors inside the parentheses, but it's going to be a lot quicker and easier for us if we first simplify anything in the parentheses. Okay, so let's start by doing that. I'm going to simplify the stuff inside the parentheses by using this rule here. So it's going to be very much like this. Okay, multiply the negative 3 times the 2. So I'm going to get negative 6. The x to the third times x to the fifth. It's going to be x to the eighth because I just add the 3 and the 5. And the y to the fourth times y to the sixth, so it's y to the 10th because I just add the 4 and the 6. Okay, and then that whole thing, so all I've done is this is the same thing as that in the parentheses, just rewritten it. Now I still need to square it. Okay, now the next rule that we'll need to use is the rule that says if you have two factors being multiplied by each other, and then that product is raised to a power, then you raise each of the individual factors to that power. Okay, so that will extend to any amount of factors within the parentheses. In this example here, we actually have 3 factors, not just 2. So I need to raise each of these individual factors here to the second power. So I'm going to need to square the negative 6. I need to square the x to the 8th. And I'm going to need to square the y to the 10th. Okay. Now because this negative 6 is in parentheses, that means this is negative 6 times negative 6, so this is going to end up being positive 36. Now if this had not been in parentheses, then it would have been negative 36, but it does have to be in parentheses, okay? So it's very important that you correctly use notation when you square any kind of negative number like this. Okay, so it's positive 36. Now to be able to do this, x to the 8th squared, we're going to have to use this rule that says if you have a factor raised to an exponent, and then that is raised to an exponent, then you simply multiply the two exponents. So here we have x to the 8th, whole thing squared. So that means I'm going to do x to the 8 times 2, or x to the 16th. This is y to the 10th squared, or y to the 20th. Okay, there are multiple ways to start this problem, but my personal preference is to always start with negative exponents. Okay, so you should kind of deal with parentheses and the exponents outside of parentheses first, And if one of them is negative, it's best to start with that one first. So what I'm going to do is I'm going to leave the 2x squared y to the negative fifth cubed alone for now. I'm going to just deal with this because it has a negative 4 as an exponent. So the rule says that if you have a negative exponent in a numerator, to make it positive, you bring it down to the denominator. If you have a negative exponent in the denominator, to make it positive, you bring it up to the numerator. So essentially, if you switch a factor's place in the fraction, you're going to change the sign on the exponent. Okay? So negative exponents are not considered simplified. So whenever you see a negative exponent, that means it's on the wrong side of the fraction bar. You want to put it on the other side so it'll have a positive exponent. Okay, so I need to, this entire thing here has a negative exponent, so I need to bring the entire thing down. As soon as you bring it down, you can make the exponent positive. Okay. So be careful with this here. A lot of students will see this negative exponent and try to go ahead and move it down. You cannot do that because you have to first deal with this cube outside of the parentheses. Okay? So the cube outside of the parentheses says cube each one of these factors. Okay, so that's using this rule here. I'm sorry, this rule here. I pointed to the wrong one. So I have x squared cubed y to the negative fifth cubed. Okay, so I'm just cubing each one of the factors, and with this one I'm going to raise each of these factors to the fourth power. Oops, I forgot to cube my 2 here. So 3 to the fourth, x to the negative fourth to the fourth, y squared to the fourth. Okay. So the nice thing about the way this is notated here is you can see all the prime factors of whatever these numbers are going to end up being. If two numbers don't share any prime factors in common, then the fraction that is created by them won't be simplifiable. So we can go ahead and write that as 8 over 81. Now it won't simplify at all throughout the rest of the problem, so we don't have to check it again. Because it's always going to be, this is only divisible by powers of 2, and this one's only divisible by powers of 3, so they won't be divisible by anything other than 1 in common. Okay, so x squared cubed, the way I'm going to do that is use this second rule here that says if you have something raised to a power and raised to a power again, you just multiply them. So it's going to be x to the 6th. Excuse me. Y to the negative 15th. X to the negative 16th, and y to the 8th. Okay. So the next thing I would prefer to do is to deal with my negative exponents, because I always like to deal with negative exponents first. Now, you could use the rule that says you subtract the exponents here, which I don't actually have written here, and that's because I'm not going to use it. But I prefer to deal with my negative exponents first, so that way I don't have to worry about subtracting negative numbers and stuff like that, because then I'm more likely to have a sign error. Okay, so the 8 and the 81, nothing's happening to those. Also, these two factors here that have positive exponents, I'm not doing anything with them either. So I'm just going to rewrite them here. The only thing I'm going to change is I'm going to deal with the things that have negative exponents. If it's in the numerator with a negative exponent, you make it positive by bringing it down to the denominator, so y to the positive 15th. If it's in the denominator with a negative exponent, you make it positive by moving it up to the numerator, so x to the 16th. Okay, we're almost done. You can't have a factor with this, two factors with the same base. Okay, so what I'm going to do is combine those by using the first rule that says if you have two factors with the same base, you just add the exponents. So the 8 and the 81, those are staying the same. So I just need to do x to the 16th plus times x to the 6, or x to the 6 plus 16. So that's going to be x to the 22. Okay. Then I do y to the 15th times y to the 8th, so just add the exponents. So it's going to be y to the, had a brain fart there, 23rd. Okay, so once you see that you don't have any factors repeating, or factors, bases of factors repeating, and no negative exponents, no parentheses, you know you're done. Okay, so whenever you see constants, you should first check and see if those will simplify. Well, they both are divisible by 3. So, actually, I'm sorry, they're both divisible by 6. So if I divide this one by 6, I'll be left with a 2, and this one by 6, I'll be left with a 3. So, 2/3 x cubed x to the 6th, y 12th, y to the 8th. Okay. So everything else stayed the same. The only thing I changed was I simplified the constants. Well, with this one, we're going to have to use a rule we haven't used so far. And there's actually 2 different ways to do this, and I'm going to show you 2 different ways. The first is to use the rule explicitly, and it says if you have 2 factors with the same base being divided by each other, you just subtract their exponents. So this would be 2/3. We're not doing anything with that. If we want to subtract this, this will be x to the negative 3, because 3 minus 6 is negative 3, and 12 minus 8 is 4, so y to the 4th. Now we have to deal with this negative exponent. The negative exponent rules say if you have a negative exponent in a numerator, then you need to bring it down to the denominator. So we have x to the 3rd down here, and y to the 4th. Now, the other way to do this would be to say, okay, notice with this x to the 3rd and x to the 6th, notice that when I took the difference between the 2 numbers, if you just don't worry about, doing them in this exact order, top minus bottom. If you just say, what's the difference between 6 and 3? You get 3. Well, notice here, there were more x's in the denominator than there were in the numerator. So when I found the difference, the result was going to end up being in the denominator. You could think of it as if we were to physically cross these things out, there's 3 x's in the top and 6 in the bottom. So the reason I want to subtract them is because I'm finding the difference. How many are going to cross out? Okay, so 3 sets of them would cross out, but because there are more in the denominator, that's where my result will be. The 3 x's will be left in the denominator, so 1 over x to the 3rd. So you can do it like that. A lot of students prefer to think of it that way. They just find the difference between the 2 exponents and say, okay, there were more x's in the denominator, so there's where my result is going to be. They find that easier than having to deal with this whole negative exponent thing. Okay, so the first thing you should always try to do is try to make sure that the constants don't simplify. If this were the fraction 15 over 25 and we didn't have any of these variables at all, you'd want to go ahead and simplify those. They're both divisible by 5, so they both have a factor of 5. So if I were to cross out the factor of 5 in each one, I'm left with a 3 and a 5. So this simplifies to 3x to the negative 6th, y to the 8th, and 5x to the 3rd, y to the negative 12. Now that didn't use any exponent rules, that was just simplifying fractions there. Okay, now my personal preference is always to deal with negative exponents first. And I know I've said that a few times, but I like to reiterate it. So let's deal with these negative exponents. So this x to the 3rd is cool, it doesn't have a negative exponent. And this y to the 8th is also cool, it doesn't have a negative exponent. But this one and this one do have negative exponents, which means they are on the wrong side of the fraction bar. So to deal with them, I'm going to just switch their position. So to give this one a positive exponent, I need to bring it down to the denominator and make it positive. To give this one a positive exponent, I need to bring it up to the numerator and make it positive. We're almost done now. Now all I need to do is say, okay, well these 2 factors have the same base, so I just need to combine them by adding their exponents, so it's y to the 20th. These 2 have the same base, so I just add their exponents, so it's going to be x to the 9th. Okay, so I always recommend before you deal with anything outside of parentheses, you first simplify anything inside the parentheses. Okay, so let's first start with the constants. 9 divided by 3 is 3. And I'll do everything else in the next step. Okay. Now let's look at these x's here, because I have an x occurring in more than one place. Whenever you have an x divided by an x, or something with the same base divided by a factor with the same base, you just find the difference between their exponents. So let's leave everything else the same. The only thing I'm going to do here is subtract the exponents on the x to the 8th and x to the 3rd, so that's going to leave me with x to the 5th. Okay. Now, whenever you find the difference between the two exponents, whichever one had the highest power exponent, that is going to tell you the position of your result. So we did 8 minus 3, we got 5. Because there are more x's in the top to begin with, the result is going to be in the top. Okay. Now at this next one, you can actually do this two ways. You can go ahead and use the rule that says find the difference between the two exponents. Then you get a y to the negative 7. But the easiest thing to do is actually say whenever you see a negative exponent, you need to bring it down to the denominator. So we have 3x to the 5th. Let's leave everything else the same. Okay, the only thing I'm going to do is deal with this negative exponent here. Because this has a negative exponent in the numerator, I want to make it positive by bringing it down to the denominator. Okay. I'm almost done here. Well, actually, I'm almost done simplifying this stuff inside the parentheses. There's still quite a bit to do. Here I have two y's being multiplied by each other. Okay, so I just need to add their exponents, so this will be x to the 7th. Now that everything inside the parentheses is completely simplified, let's now use the rule that says if you have a fraction raised to an exponent, you raise the numerator to that exponent and you raise the denominator to that exponent. And I'm going to start doing this a little horizontally so I don't run out of room. So I need to raise the entire numerator to the 2nd power and the entire denominator to the 2nd power. Now whenever you have two things being multiplied by each other raised to an exponent, you just need to raise each of those factors to the exponent. And we'll just leave this one alone for a minute. Okay. Well, 3 squared is just 9. X to the 5th squared, whenever you see something raised to a power, then raised to a power again, you just multiply the power, so that's x to the 10th. Y to the 7th squared will be y to the 14th. One thing that a lot of students do, instead of using this step here, they'll just go ahead and jump straight from this step to this step. Okay. The reason they do that is they'll say, okay, well, if I'm going to raise the entire numerator to this 2nd power and the entire denominator to the 2nd power, essentially all I'm going to do is raise every single factor inside the parentheses to that power. Notice the 3 got raised to the 2nd power, so did the x to the 5th and the y to the 7th. So you can skip this step and just jump straight to this by recognizing that pattern. Now I want to point out that the ways to tell when you're done simplifying these expressions, a lot of students have trouble telling when they're done. For example, with the one up here, well actually let's go to this one here. A lot of students will stop at this point. Okay, they'll say, oh, I got rid of all my negative exponents, I'm done. Well, there are 3 things that need to be true for you to know that these expressions are completely simplified. The first 2 are real easy to check. No parentheses. Okay, if it has no parentheses, then it has to have no parentheses to be simplified. It can also not have negative exponents. Okay. So the one that's a little more difficult to tell is that no two factors can have the same base. So what I mean by that is, notice in this example here, this one was not done because notice each of these factors had a base of y. Each of these factors had a base of x. So you can't have that. You can't have two factors with the same base. Okay. So the way I've always thought of it is also in this one. Notice I have an x here and here, and a y here and here. The way I've always thought of it is you can't have a variable occurring in more than one place. Here, x occurs in more than one place. Here, x occurs in more than one place. We only want to see one x with one exponent. Once that's true, then you know you're done. And same is true for the y's and so forth.